Hello and welcome to another session of Leetcode. Today we are doing longest increasing subsequence. This is one of the classic interview problems. So you have been given an unsorted array and you have to find the length of the longest increasing subsequence. So one thing to note is a subsequence may not be necessarily contiguous. So in this example, 2, 3, 7, and 101 yield to 4 and they are not continuous, right? So let's So the key to understand this problem is to take a pen and a paper and walk through the example. And once you understand the nuance of it, I think it becomes very easy to understand the whole problem. So let's take an example. So if I ask you, you have been given an array with just one number, okay? And what is the maximum length of this array? And you would say 1. And this DP includes the result of maximum length up to that index, including that number. So that's the distinction. It doesn't just include the result up to that index, but it includes result up to that index by including that number. And this will become more clear in a moment. Okay, this is great. Now let's say if I give you another number 6. So, and I ask you, okay, what is the result of dp1, which is this value, what would be the value here? And you would say, okay, I can compare 6 with 2, and 6 is greater than 2. So I would require to add 6 to the result which I've already obtained, and which is 1. So you would say the result would be 2. And as I said before, this 2 is the result of increasing subsequence until this index, but most importantly, it also includes 6. All right. So let's say if I give you another number 8 and I ask you the same thing, and you would say, I would compare 8 with the first result I obtained, which is 1, and I would compare 2 and 8, and since 8 is greater than 2, uh, I can include 8 in this solution, right? And I don't care how I obtain this solution, but I know if 2 is greater than 8, I can include 8 in this solution. So one of the possible candidates or the possible result would be including 2 and 8. So in this question, we don't care about the actual numbers which make the subsequence, but I think it's easier to understand. So we are saying we'll add 1 to this result because we are including 8 in this result, right? So the result would be 2. All right, so now we compare and we keep iterating forward, and now we compare 6 and 8. So essentially, we're looking if we can include +1 in this result. And since 8 is greater than 6, 8 can be included in this result, right? And you don't care how you compute this result. You don't care if you are including the previous values or not. All you care about is the element I'm comparing, the current element, is that element greater than uh, this number 6? And if it is, then I can include that number and add +1. So another possible candidate is 2, 6, and 8, and the result is 3, right? So now let's take another number, -1. And this is interesting. This is where things will become very clear. So now I'm looking at -1 and I'm saying, okay, is 2 greater than -1? And it is. So you cannot include -1 in this result, right? Same thing here. you compare 6 with -1 and you're saying, can I include -1 in this result? And the answer is no. Then you compare -1 with 8 and you cannot include -1 in this result as well. And so since you do not include any of that, you're saying the answer would be 1 because I would just take -1 in itself. So as you can see, this dp of, so this is the third index, so dp of 3 is 1, which indicates that I've computed result up to index 3 by including that number. So I'm not saying this value is not 3 because I have to make sure that I include this index, this number as well, right? All right, great. So as you can see that you're building this results and your final result would be the maximum of the results that you have computed. Okay, so now let's take another number 9. And you're doing the same thing for 9. You're saying, okay, if can 9 be included in this result? And since 9 is greater than 2, you're saying, okay, it can be. So 2 and 9 are possible solution, and the length would be 2. Length would be 2 because you already have the length 1, and then you're including 9, so you add +1. Same thing here, so you're saying, can 9 be included in this result? And since 9 is greater than 6, you can include that. And then you add 1 to the result because you're including 9. And again, you don't care how you get this 2. You don't care about the numbers which are forming the subsequence in this problem. You only care about the length. And same thing you do for 8 and 9. So you compare 8 and 9 and you're saying 9 is greater than 8. So I can include +1 in this result. And next possible candidate is 4. Then you're saying, okay, -1, and can I include 9 into this result? And you can, because 9 is greater than -1, so you can include 9 into this result. So another possible candidate is -1 and 9, and the length is 2. And then you have to pick the maximum of the possible candidates you have obtained so far, right? So in our case, that would be 4, which is obtained by this sequence. And the final result, and as you can see, the final result, okay, let's take one more number. Let's take -3. So you do the same thing for -3, you keep comparing it with all the numbers, and you can see that you compare -3 with 2, 6, 8, -1, and 9. And since -3 is smaller than all of them, you will not include them in any of these results. And you would say, I would just take -3 on its own, and it would have a length of 1. And that is a possible candidate too, -3, right, by itself. And the length would be 1. And as you can see, the final result is the maximum of this results, this DP array, which is 4. So you have to make sure that in the end you return what is the maximum value in this DP array. All right, so let's get into the code, and it will be more clear once we start coding. I'm going to leave this as it is. So let's take our result variable, and let's create a DP array. And the first result would be 1 because the length of element itself can be 1. And then we start our loop with 1. And then we keep comparing till the I element, I index. And I'm saying so what do I need to do here is I want to compare the maximum result. So out of all this possible candidate, I want to select which one is the maximum. And uh, then I would assign that value to the dp of I. So I want to say temp would be, and then if I'm including that result, I'm adding 1. That implies that I'm including the value dp of I. And I want to do this only when my element nums of I is greater than the element at index j, right? Okay, and then I'm gonna assign this value dp, this value temp to dp of I, and the final result would be the maximum for all the values in dp as we discussed. So all right. All right. So thank you for watching. Please let me know if you don't understand any of the any if you don't understand anything, or leave a comment and subscribe to the channel. Thanks.